Okay, here's a video on complex addition showing that it's associative. That means if you add two numbers and then add another number on the left, it's the same as adding the two numbers on the left first and then the number on the right. This is perhaps a little counterintuitive because most of the operations you know are associative, so you don't really worry about them. But here's how we verify it. We're actually going to borrow from the fact that you know that real numbers are associative. So we'll let u equal a1 plus b1i, w equal a2 plus b2i, and z equal a3 plus b3i. Okay, and now, so a1, a2, a3, b1, b2, and b3 are real. Okay, and by real, that means that associativity applies to addition of those. So, u plus w plus z equals, let's see, a1 plus b1i plus a2 plus b2i plus a3 plus b3i. Okay, so I've just taken the definition of what those are. Now I'm going to combine these two numbers using complex addition. So what's complex addition do? It adds the real parts and it adds the imaginary parts. So by complex addition, a1 plus b1i plus, what is this thing? It's a2 plus a3 plus b2 plus b3i. That is a complex number. Okay, we added the real parts, we added the imaginary parts. Now I'm going to say by complex addition, I'm going to add the real part of this and the real part of that. Okay, so that says the real parts of these all combined is a1 plus the quantity a2 plus a3. Keeping parentheses, this is just by definition, it's this real part plus this real part. That's all the real part, plus same thing for the imaginary parts. b1 plus b2 plus b3 I. Okay, now all I need to do is recognize these are three real numbers, and I will say real addition is associative. In other words, if you have three real numbers, you can add the two on the right first, or you can take the exact same thing and add the two on the left first. And as long as real addition is associative, you can probably see where we're going here. Then this is going to be, by definition of complex addition, just this process with the parentheses in the other place. So what is this? Well, that is equal to a1 plus a2 plus b1 plus b2 I plus a3 plus b3i. that's just the definition. If you look at these two, this is just the definition of complex addition. Similarly, if you look at this right here, that's basically just the definition of complex addition, where that bracket there says a1 plus b1i plus a2 plus b2i is the thing in there, just by complex addition. Okay, and of course this term just kicks around at the end. We didn't do anything to it. And what is this? Well, that is U, this is W, and this is Z. So there is a proof of complex associativity.